Before banks existed, before paper money existed, before numbers even had names, people still owed each other things, and someone had to figure out how to write that down. The answer they came up with was so strange, so counterintuitive, so philosophically offensive that Europe's greatest mathematicians spent 1,000 years refusing to accept it. And then a physicist used it to discover something hiding inside the universe. This is the story of how ancient humans counted money, and how that problem accidentally explained half of everything that exists. Ancient China, first millennium BCE. No banks, no receipts, no credit cards, just people, and the things they owed each other. Here's the problem nobody could solve. You have 0 coins, but you owe someone 10. That's not 0. That's worse than 0. How do you write that down? You can't just leave an empty space. An empty space means nothing. But a debt isn't nothing. A debt has weight. It has consequence. It can ruin you. So Chinese merchants invented something. 2 colors of counting rods. Red rods for money coming in. Black rods for money going out. Lay them on a bamboo grid, and at a glance, you could see exactly where you stood. No confusion, no mistakes, no bankruptcy. This is why we still say someone is in the red today. 2,500 years later, same idea. Different color. Meanwhile, on the other side of the Himalayas, Indian mathematicians were doing the same thing, independently. Without knowing about the Chinese rods, they started writing negative quantities into their equations, sometimes marking them with a small dot, sometimes with a plus sign, the opposite of what we use today. 2 civilizations, separated by mountains, arriving at the same answer, because the problem was the same. How do you represent something that is less than nothing? Here's where it gets strange. 1,000 years later, European mathematicians knew about negative numbers, and they refused to use them, not because they were stupid, but because they were certain the numbers were wrong. In 1544, a mathematician named Michael Stifel had a name for them: numeri absurdi, absurd numbers. Descartes, one of the most brilliant minds in Western history, called negative solutions to equations false roots as late as 1637. Their logic made complete sense. A number has to represent something real. A length, a weight, a volume. Show me negative 3 apples. You can't. So the number isn't real. The result? European mathematicians spent centuries writing equations that were pages long just to avoid a single minus sign. Problems that should have taken 1 line took an entire paragraph. Nature doesn't have negative numbers. Ledgers do, and the ledger won. In 1928, a British physicist named Paul Dirac was trying to write an equation that described the electron. He wrote it. It worked perfectly, but it gave him 2 answers. One described the electron exactly as expected, negative charge, specific mass, perfectly observable. The other described something that shouldn't exist, a particle with the same size as an electron, but with the opposite charge, something no one had ever seen, something that, as far as anyone knew, didn't exist anywhere in the universe. Every physicist in that room would have deleted the second answer, called it a mistake. Dirac didn't. He said, "This is real. We just haven't found it yet." 4 years later, Carl Anderson was running an experiment at Caltech. He found it. Same size as an electron. Opposite charge. The first piece of antimatter ever detected. The number that Michael Stifel called absurd in 1544 turned out to describe half the matter in the universe. So how did ancient humans count money? With colored rods on a bamboo grid. A merchant in China needed to track a debt, something that was less than nothing, and built a system so powerful that 2,000 years later, a physicist used the same logic to find antimatter. The Chinese merchant wasn't doing physics. He was trying not to go bankrupt, but the problem was the same. How do you count something that shouldn't exist? Every time humans accepted that question, the world got bigger, not because the universe changed, because we finally built a lens that could see it, which makes you wonder, what are we still refusing to count today?